Let's finish off inverse functions. What we saw in the previous video is the big thing inverse functions do is they switch the x's and the y's. So to find the inverse function of this, what we're going to do is we're going to write y equals 2/3 x minus 6. And really the reason we write y is it's easier to write than f of x. That's it. And then, like I say, the big thing we noticed is inverse functions switch the x and the y. So I'm going to switch x and y. I'm going to write x on this side, and I'm going to write 2/3 y minus 6 on that side. And then what I need to do is I need to get this y all by itself. To get the y all by itself, I would add 6 to both sides. And then to get rid of a 2/3, I would multiply by a 3/2. And then the 3 is reduced, the 2 is reduced. I get y equals 3/2 times x plus 6. So the answer is f inverse of x is 3/2 times x plus 6. So that's how we find an inverse. To find the inverse, we use the information that x's and y's switch, so we switch them, and then we solve. Second one, y equals 4x minus 2 over 5. Again, I switch the x and the y, so I write x equals 4y minus 2 over 5. I want to get that y all by itself. To get that y all by itself, I would start by multiplying both sides by 5. So 5x is 4y minus 2. Add 2 to both sides. 5x plus 2 is 4y. And finally, divide by 4. So y is 5x plus 2 over 4. So the answer to the question is G inverse is 5x plus 2 over 4. All right, now things are slightly different when we deal with an application. So we got one application to deal with here. The global revenue from ebooks are shown in the table below. So this is from 2011 to 2015, and you can see the revenue here in billions of dollars. A lot of money. Let R equal f of t be the annual global revenue in billions of dollars from ebooks, t years since 2010. Is the data best modeled by a linear function, a quadratic function, or an exponential function? Well, looking at it, I think the data is linear. And the reason I say that is I notice when I go from here to here, I go up by about 2. When I go from here to here, I go up by about 2. Up by about 2, up by about 2. So it looks like every year I'm gaining about $2 billion in revenue. Now, I went ahead and I typed the data in, and I drew a graph just to check. And it does look like that data is pretty linear. So my answer would be, it's linear. And if it were on a test, I could give one of two answers. I could say revenue increases by about 2 each year. Or I could say, I drew the graph and I looked at it, and it really looked linear. All right, so to find the equation, stat, calculate, we decided it's linear. We get 2.322 plus 1.682. So R equals f of t is 2.322t plus 1.682. Now, here's what's slightly different. When we're dealing with an application, when we have R and T, and they stand for specific things, R is the revenue, T is years, we don't switch the letters. So to find F inverse, what we're going to do is we write this as R equals 2.322t plus 1.682. And then what we're going to do is we're just going to solve this equation for t. Subtract r minus 1.682 equals 2.322t, which means t is r minus 1.682 divided by 2.322. So notice what we have. We really have the same equation written twice, just in two different forms. We would tend to use this equation if we were given a time value and we wanted to find r, because we would just plug in and grab our calculator and work it out. We would tend to use this equation if we were given an r value and wanted to find the time. Now the truth is you can use either one in either situation. It's just a matter of how easy is it. For example, it says use F to predict when the global revenues will be 30 billion. So it's telling me use this one. And revenue is 30, so I plug 30 in right there. I would have 30 equals 2.322t plus 1.682. And notice the work I have to do. I have to get the t all by itself, which is really the exact same work I did in part C, except I had a letter instead of a number. All right, so I would do 30 minus 1.682. 30 minus 1.682. 28.318. 28.318 equals 2.322t. And then I would divide. T is divided by 2.322. About 12 years. Turns out to be 12.2, we would call it. I'm just going to go with 12 years. Part E really asks us to do the exact same thing. Use F inverse to predict when revenue will be 30. Slightly easier this time really because we already have the equation solved for us. Our answer would be T equals 30 minus 1.682 divided by 2.322. And we really don't have to do the algebra. We get the same answer. We use our calculator. 30 minus 1.682 divided by 2.322, and we get exactly the same answer. All right, so notice the slight difference. When we're just dealing with regular old functions, x's and y's, we switch the x and y's because x and y don't really have any meaning to us in this problem. Here, r and t have very specific meanings, so it doesn't work to switch them. We want to leave them as r and t because r is always the revenue and t is always the time. So in these application problems that you'll do, don't switch the letters. When it says find the inverse, just take your equation and rewrite it, solving it for the other letter. Okay, well, that's the end of inverse functions. Once again, you're ready to work on the homework and the quizzes. And once again, as always, if you have questions, please let me know.